First question is, the ideal gas was subject to a reversible adiabatic expansion, and then its initial volume was restored by a reversible isothermal compression. Okay, the Q denotes the heat added to the system, and the W work done by the system. Then, okay, the first statement is so it is useless. Okay, it is given to distract you or to waste your time. Okay, the second statement is Q denotes Q added to the system, and the W denotes work done by the system. Okay, Q added to the system means Q equal to positive, means Q is equal to greater than 0. Okay? And work done by the system means work done by the system means work is negative and work is less than 0. Okay? So work is less than 0, this is the answer. Okay? Then the bomb calorimeter, the compression of 0.5 gram of compound A, molar mass 15 gram per mole increased by the temperature by 4 Kelvin. If the keep capacity of the calorimeter along with that of material is 2.5 kilojoule per Kelvin. The molar internal energy of compression in kilojoule. Okay. They asked molar internal energy. Okay. So the relation between heat capacity and molar and TU equal to CVD. Okay. CV. Okay. Or CV equal to dou U by dou T. Same. Okay. At constant V. Yes, this is the formula. So they give the CV and the DT. Just to multiply this, they get DU. Okay. Then using the formula mole, they give 0.5 gram and molar mass is 50 gram per mole. So moles is 1 into 10 power minus 2 moles. So molar internal energy is internal energy divided by moles. Okay. So you got the molar internal energy. Okay. 10 kilojoule per mole. The correct answer is 1000 kilojoule. Here they missed out per mole. Okay, so molar internal energy means you should contain the moles, but in the question also it is wrong. The correct statement for any cyclic thermodynamic process. Okay, the morning class I told like dq is not equal to 0 and the dw is not equal to 0. Only du equal to 0. Okay, the q and work are path independent. Okay, so it is not a state function. Okay, path dependent. Okay? It is not a state function. So for a cyclic process it is not equal to 0. Okay, cyclic process it is not equal to 0. And here also the dq is not equal to 0 and the volume cannot be 0. Okay, so multiplying a non-zero value with non-zero value you cannot get a 0. Okay, this is also wrong. Okay, which of the following statement is true for the cyclic process? Okay, so this is wrong, this is wrong. Heat can be completely converted into work, work can be completely converted to work. So this in it is in second law. Okay, so heat cannot be uh, completely converted into work. Okay, it is wrong. Work can be completely converted into heat. Okay? The heat capacity of 10 mole of an ideal gas is at a certain temperature is 300 joules per Kelvin at constant pressure. The heat capacity of the same gas at the same temperature and at the constant volume. So they give the heat capacity at constant pressure and they asked heat capacity at constant volume. Okay, you should know the relation between these two ideal gas. Okay, so this is the relation Cp minus Cv equal to N. Okay, so they asked us Cv. Okay, Cv is equal to Cp minus Nr. Okay, so you got the answer. Okay, simply we can derive this relation in the next class. Okay? Among work, heat, and internal energy and entropy, work and U are path functions. U are not a path function. So and Q and A are Q is heat, S and S entropy. Okay, they give. So we know Q and U are path function, and S U and S are state function. We saw entropy S in later classes, but S also is a state function. Okay. This is for a certain amount of gas, not necessarily ideal, is changed from A to B in various hypothetical paths shown below. the total amount of the gas remains constant. Okay. So which of the following bars are physically reliable? Okay, so the only the constant is total amount of gas is remain constant, and it is not a ideal gas. Okay, not necessarily an ideal gas. Okay, means it is a real gas. Okay, so I think all bars are physically reliable. Asked which are physically reliable means which operations you can perform in the physical world really. Okay, so you can operate, it is a constant pressure path and it is a constant volume, it is reliable, and this also like that. It is a this process also physically reliable. By increasing the volume, that the pressure should decrease. Okay, so like that, this process also possible, this process also possible. Okay, so the all of them are physically reliable. Okay, so if the pressure of the system is greater than the surrounding, then so here the pressure inside the system is higher. Okay, means if we here if we piston mean higher than the surrounding means uh, uh, the piston move out. Okay, so the system is worked, does work. Okay, so work is done on the surrounding by the system. The system is doing work because this is high, in the high pressure, the surrounding is in the low pressure. Okay, so this is the correct answer. Okay, so these are the simple previous year questions from the work, heat and the analysis. Thank you.